All right, here we go. 2.7. There was a lot of information in 2.6 and 2.5. Okay, a lot of information about transformations. This one we're going back to the basics. We're talking about operations and functions. All right, more specifically, today we're doing in this video we'll do operations. In the next video, part 2, we'll do compositions and functions. Okay, so we're going to talk about basic operations: addition, subtraction, multiplication, and division. All right, first of all, this right here, what does this mean? This means, okay, f of x plus g of x. This does not mean f plus g times x. What we're literally doing is we're adding our two functions together. All right, we're going to be given two functions, and we're going to combine those two. All right, here again, we're not multiplying, we're subtracting our two functions. Now, the important thing about this one, when subtracting, remember that order matters. Okay, if f comes first, then you must write f first. All right, this is f times g of x. So f of x times g of x. And make sure to pay attention to whether or not that dot is open or closed, because when it's open, it's going to mean something different, which we'll find out in our next video. Okay, but here it's closed, so we're using multiplication. And lastly, we're going f of x, you guessed it, wow, divided by g of x. And just like with subtraction, order matters here too. Okay? Note that we are not multiplying any of these functions by x. All right, we're not multiplying any functions by x. We're adding, subtracting, multiplying, or dividing. All right, so let's give it a shot here. Okay, so we want to, in each of these things, we'll perform three basic operations. All right. In our first one, we're doing f of x minus g of x, which could also look like this. Whoops. Like this, f minus g of x. That would be the same thing. Okay. So here I'm going to write, I have f of x, which is 3x squared plus 6x minus 4, and then minus g minus x squared minus 8. Now make sure you put g in parentheses. That's very important because we are going to do what? We're going to distribute our negative here. Okay, so it's very important that you put your second function in parentheses so we can distribute our negative, so that 8 becomes positive, and then combine our like terms to get 2x squared plus 6x plus 4. All right, and for each of these, we want to state our domain. Well, the domain of a squared function is all real numbers, so negative infinity to infinity. Okay. All right, next we got g of x plus f of x. So g of x is, what the buckets? Okay, let's try that again. Holy buckets there. X squared minus 8. Plus f of x, which is 3x squared plus 6x minus 4. Alright, again, combine your like terms. You should have 4x squared plus 6x minus 12. Okay, in your domain, again, squared function, so all reals. Negative infinity to infinity. Okay, I notice I'm going pretty quickly. Hopefully you're going pretty quickly through these two. Alright. Here we go. So here, notice we have 2 times g of x minus 3 times f of x. So 2 times g of x minus 3 times f of x. And notice again that I put that f of x in parentheses. Okay, even if the 3 was not here, I would still put that in parentheses. Okay, so now we do a little distributing action. 2x squared minus 16. Wow. Minus. What? No, not yellow. Let's go red. Here we go. Minus 3. Okay, so negative 9x squared minus 18x plus 12. Combine your like terms. Negative 7x squared minus 18x minus 4. Excuse me, minus 4. All right, and our domain again is all real numbers because it's squared. Okay, here we go. Let's keep going. F times g of x. All right, so now, remember this can also be written as f times g of x. All right, f of x was red. Yeah, red. Okay, so f, we have a new function for f. We should have a new function for f, so I do 3x minus 4 times my g, which is 2x plus 1. Multiplying a binomial times a binomial, so we just FOIL it up. Alright, or lobster claw it up. I don't know if anyone knows that one. Alright, so 3, where am I going? Minus 3, excuse me, plus 3x. Confused myself there. Minus 8x. Minus 4, which gives me 6x squared minus 5x minus 4. Alright? Yeah. Okay. And again, quadratic, domain, all real numbers. Alright, and this next one, we're dividing f of x by g of x. Remember, order matters. This could also be written f divided by g of x or f g of x, like that as well. Okay? So order matters here. So f is on top, so 3x minus, what was it? 4? Yep. Over 2x plus 1. Alright? Now, what are the restrictions on the domain? Okay? Remember, in fractions, there's a number, from our reciprocal function, there's a number that we cannot divide by. Well, that number that we cannot divide is what? Say it. Goose egg. 0. So my denominator cannot be equal to 0. So that my denominator cannot equal 0. So we want to find the value of x that will give us 0. So I'm going to subtract 1. 2x does not equal negative 1. And divide by 2 to get x. X cannot equal negative 1/2. So our domain will be negative infinity to negative 1/2. Skip 1/2, pick it back, or skip negative 1/2, pick it back up again, negative 1/2 to infinity. Boom. Again, we're moving kind of quickly through this. That's all right. We can handle it. We got this. All right. One more. Another one. There we go. F of x is x squared minus 5. G of x is x plus 4. So, here we go. Order matters. F of x divided by g of x. X squared minus 5 over x plus 4. Domain. Okay. The bottom, our denominator, cannot equal 0. So x cannot equal negative 4. Wow. This is fun stuff. What do you do on the weekends? You're looking at it. This is me doing fun on the weekend. So, here we go. Domain. Negative infinity to negative 4. Pick it back up. Negative 4 to infinity. Alright. I want you to pause the video here, okay, and try to find the domain of g divided by f. G of x divided by f of x. Pause it. Alright, here we go. So, find domain. So, our denominator cannot equal 0, therefore x squared minus 5 cannot equal 0. Add 5. To get rid of a square term, we square root both sides. Remember, when solving, okay, with square roots, it's plus or minus root 5. Okay, don't just write root 5 here, because that will affect your domain. So domain is from negative infinity to negative root 5. Pick it back up, negative root 5 to positive root 5. Pick it back up, positive root 5 to infinity. Alright, hopefully these are getting a little bit better. Here we go. Oh boy, let's look at a graph. Okay, so in the past we're used to just f minus g of x, f of x minus g of x. Well, instead of the x here, all right, now I have a 3. So all we're going to do here is we're going to find f of 3 and subtract g of 3. Okay? So I'm going to go over to 3. F of 3 is right here, which is 2. G of 3 is right there, which is 0. So my answer is 2. Boom. Okay. Next thing I want to figure out, all right, there's 3 questions. Where is g of x, or f of x minus g of x positive? Where is f of x minus g of x negative? And where is it equal to 0? So let's break it down. So where is it positive? That means that f of x, in order for it to be positive, must be greater than g of x. So let's look at our functions here. Look at our graph. Where is f of x greater than g of x? Here and there. All right? In 2 pieces. So right here and to there. Okay? So where is it positive? Let's talk to it. From including -1 to 0. Don't include 0. Pick it back up from 2 to 5. And don't include 5. Alright? Where is f of x negative? Or should be f minus g of x negative? Well, that's when f of x is less than g of x. So when does that happen? Okay. Well, that confused myself there. So where is f of x less than g of x? Well, f of x is less than g of x from here to there, and then on this part here. Okay, so that looks like that's from 0 to 2, and then from 5, and we'll call that 6. So from 0 to 2, pick it back up. There you go. From 5, and then I guess we can include 6. All right. Lastly, where is it 0? F of x minus g of x. Well, if we know anything about functions, that's when our functions are equal, or where they intersect. Where do they meet on our graph? Okay, think about systems of equations. All right, well, our systems intersect here, intersect there, intersect there. So x equals 0, x equals 2, and x equals 5. So where are they equal? At x equals 0, x equals 2, and x equals 5. Alright. There you have it. Next up, composition of functions. Oh boy.